This repo lets you control drones and robots with vibe-coded instructions. Dimensional, or DimOS, is an open-source operating system for physical space. It is basically Claude code for robots. Agents can run modules, call skills, read sensor streams, and operate hardware through a real software stack. This is not a toy chat demo. It is a bet that robots need an agent native runtime.
The README describes Dimensional as a modern operating system for generalist robotics. In plain English, it is trying to make robot applications feel more like software projects. You define modules, wire them into blueprints, expose skills, and then run those blueprints from the DimOS command line. The repo supports replay, simulation, and real hardware, so a developer can test behavior before standing next to an expensive machine.
The agent native part is not just branding. The repo has an agents.md file written specifically for coding agents. It tells OpenClaw, Claude Code, Cursor, and similar tools how the architecture works, which commands to run, how skills are exposed, and how to debug a running robot stack. That matters because robotics code usually has a lot of hidden state. DimOS tries to make that state legible to an agent before the agent starts changing things.
The capability surface is broad, but the center is clear. DimOS is built around navigation, perception, spatial memory, manipulation, visualization, and agent control. A quadruped can run a replay with mapping and planning. A humanoid can run in Mujiko simulation. A drone can replay video and telemetry. The same command style is used across those bodies, which is the part that makes the project feel like a platform instead of a folder of demos.
Spatial memory is one of the strongest ideas in the repo. Robots do not just need to answer what is in the current frame. They need to remember where things were, how places connect, and what changed over time. The latest release talks about temporal spatial memory for hours of video and LiDAR. That is the kind of memory that lets a robot answer questions like who was in a room, where an object moved, or which area is usually active.
The repo has real traction for a robotics framework. GitHub shows 3,202 stars, 575 forks, Python as the primary language, and 31 subscribers. The repository was created in October 2024, pushed again on May 7, 2026, and the current package version is 0.0.11. The license file is Apache 2.0, even though the GitHub API does not classify it cleanly. For robotics infrastructure, that is a meaningful adoption signal.
The repository layout backs up the pitch. The README starts with the operating system idea, then moves into hardware support, installation, featured run files, agent CLI, MCP, modules, blueprints, and development. The agents file is even more practical. It explains the module system, blueprint wiring, transport options, CLI commands, and skill rules in the language a coding agent needs. You can tell the project is trying to make robots programmable from both sides, humans and agents.
The core abstraction is the module. A module is a robot subsystem with typed inputs, typed outputs, and callable methods. A camera module can publish images. A planner can consume pose data. A control module can accept velocity commands. Instead of everything living in one process, DimOS treats these pieces as separate workers connected by streams. That gives the system a shape agents can inspect without pretending the robot is just one giant function call.
Blueprints are how DimOS turns those modules into runnable robot stacks. The AutoConnect function wires modules by matching stream names and message types. If the automatic wiring is not right, a blueprint can remap streams or swap transports. That is a practical robotics choice. Real robots rarely have perfectly clean interfaces, and a platform needs a way to compose perception, planning, control, and agent behavior without rewriting every module.
Skills are where the agent crosses into the physical world. A method marked as a skill becomes a tool the agent can call, as long as it has a docstring, typed parameters, and a useful return string. That sounds small, but it is a major boundary. The agent is not just generating code or text. It can ask a running robot to move, observe, navigate, speak, follow a person, or call a robot-specific capability exposed by the active blueprint.
The MCP layer makes this more interesting for modern agent workflows. The current docs say the MCP-enabled go-to blueprint can expose skill methods over an HTTP MCP server, and the CLI can list tools, call tools, show status, and inspect modules. That means an external agent does not need to be embedded directly inside the robot process. It can connect to a running stack, see what tools exist, and issue constrained calls through the server.
Simulation and replay are important because most people do not have a robot sitting next to their desk. DimOS includes commands for replaying unitary go-to data, running a G1 humanoid in MuJoCo simulation, testing agentic go-to behavior with MCP, and running a webcam demo without hardware. That lowers the learning curve. You can inspect the architecture and practice the workflow before a real robot becomes part of the loop.
The command line is treated like a real operations surface. You can start a blueprint as a daemon, check status, follow logs, send a message to the agent, call an MCP skill, and stop the run cleanly. This is one place where DimOS is trying to be better than a pile of robotics scripts. The run has lifecycle, logs, status, and a registry. That makes it easier for both a person and an agent to understand what is currently alive. Visualization is not a cosmetic detail in robotics. If the robot thinks a chair is a wall or a point cloud is drifting, the operator needs to see it. DimOS uses rerun-style visualization, and the latest release made the native viewer the default. It also added Click to Navigate, where a point in the 3D view can become a point-stamped target and feed the planner. That is the right kind of interface: visual, inspectable, and tied to actual robot behavior.
The hardware story is wider than one demo robot. The README names Unitary Go2, Unitary B1, Unitary G1, XARM, Agilex Piper, Mavlink, DJI Mavic, and Force Torque sensors. The support levels vary, and some pieces are still experimental. That is normal for a robotic stack. The useful signal is that DimOS is designed around multiple bodies from the beginning, rather than hard-coding one robot and calling it a platform. The latest GitHub release, v0.0.11 from March 12, 2026, is especially relevant to agent builders. It added an agent onboarding file, MCP server and CLI tooling, agent context logging, daemon mode, structured logs, temporal spatial memory, drone updates, and viewer improvements. The headline is not one single feature. It is the project shifting toward a runtime that coding agents can operate, test, and debug more directly. Compared with a plain robotic stack, the advantage is the agent-facing structure. ROS is powerful, and DimOS can interoperate with ROS2 through transports, but traditional robot middleware was not designed around large language model agents. DimOS gives the agent clearer handles: blueprints, modules, skills, logs, replay, simulation, and MCP. Compared with a generic agent framework, it is closer to the hardware. It understands streams, sensors, planners, and real robot lifecycle.
The trade-offs are serious. This is pre-release robotics infrastructure, not a polished consumer product. The dependency surface is large, hardware support varies, and real robots can fail in ways a software demo cannot. Running on hardware means network setup, drivers, safety checks, sensors, and physical space all matter. DimOS is promising because it makes those systems more programmable, but it does not make robotics easy or automatically safe.
The people who should study this are robotics developers, agent infrastructure builders, research labs, and hardware startups. If you are building a robot application, DimOS shows a Python-first way to organize streams, skills, and blueprints. If you are building agents, it shows what tool use looks like when the tools are physical. And if you are watching the agent market, this repo is a reminder that agents are moving beyond browsers, terminals, and code editors.
Bottom line, DimOS is trying to become the agent-native software layer for robots. It gives physical systems a structure that looks more like modern software: commands, modules, logs, tools, memory, simulation, and a documented path for coding agents. The repo is early, but the direction is clear. If agents are going to operate in the physical world, they need more than prompts. they need operating systems for the machines around them. For more GitHub repo deep dive videos, subscribe to Build Things with AI.